My name is James Thomas, and I'm a developer advocate for IBM working in our cloud division. And today I'm going to be talking to you about a new way to build and run Swift microservices, Swift backends, Swift APIs in the cloud without having to set up or manage any infrastructure to be able to do this. Right now, having to provision virtual machines, having to create containers, and having to set up or Linux, set up and manage Linux environments or any of that kind of stuff. I need to do the microphone, it's very important. So now having to set up Linux environments and any of that kind of stuff. And you might think that this sounds kind of impossible. Technical difficulties. It doesn't matter for me, and it doesn't matter for any of you in the room. Hello. Okay, so where was I? You might think it sounds kind of impossible, right? Swift without servers. Surely if you want to run your Swift backend in the cloud, you have to set up and manage the environment to be able to do this. But I'm going to be showing you a new approach using what they call serverless cloud platforms that allow you to do just that. And in the second half of this talk, I'm going to be doing some live demonstrations of using one of these platforms to give you the skills and techniques to go away and do this yourself. Now, as well as thinking that this sounds kind of impossible, right? Swift without servers. You might also think that it sounds unnecessary, right? You might think, I like my servers. I've got them all set up and configured just how I want them. Why would you want to take my servers away from me? Well, the reason is this, right? Servers kill your productivity. You might not realize it yet, but trust me, it's true. And I think by the end of this talk, you're going to agree with me that servers kill your productivity. You're going to want to go back to your office, gather up all of those Linux machines you've got, set them on fire, and be free forever of the tyranny of looking after infrastructure. Right? I think servers are just one of the worst things that's ever happened to software developers. So why am I so convinced, right, that servers kill your productivity? Well, imagine that you've got a great new idea for a new mobile application, and you now know that you can write server-side Swift. So you're going to build some back-end services to go with it. So you finish the mobile app and you write the back-end services, and then you think, okay, I just need to provision myself a server, and I can put the Swift on the server, and then I can release my application. But as soon as you provision that first environment, suddenly you realize you've got all these extra tasks to take care of. If you're using things like infrastructure as a service, you have to set up and manage the VM, put Linux on there, and the middleware, and the libraries, and all that kind of stuff. You have to monitor it when it's running in production, make sure it's healthy. You need to think about security. Is it backed up? Is it encrypted? Is it secure? You need to think about capacity planning. You know, how big a server do you need? How much memory and CPU and disk space? And then hopefully, if your server gets popular or your service gets popular, you're going to need to think about scaling. And scaling for most people means more servers, more environments, more VMs. And then you can run them in a cluster. You can worry about all this really, really hard distributed system stuff. And after a while, I think as a software developer, you can find yourself being held hostage by your infrastructure, right? You want to spend all your time in Xcode writing Swift. You're going to spend increasing amounts of it logged into some remote Linux VM trying to fix some production issue. Now, at this point, again, you might want to stop me and say, well, hold on a minute, right? Wasn't the cloud supposed to fix all of this? I've always been told as long as I put my back end in the cloud, all of my infrastructure challenges kind of magically go away. And I think in the technology industry, we often sell cloud as this utopian vision, right? The cloud allows you to treat computing resources as a kind of utility model like electricity or gas or water, where you just provision as much resources as you need on demand. You pay for what you kind of provision, and then when you're done, you kind of throw it away. But for many of us who do build backends in the cloud today, I think the way that we use computing resource, computing infrastructure in the cloud is a long way from what I think of as a kind of utility model for computing. So let's do a comparison, right? Let's think about how we use a utility like electricity and then compare how we actually use computing infrastructure in the cloud. So I've got a couple of questions to ask you. Right, you know, you all use electricity from your provider. Right? Does your utility provider, do they ask you to go down at the weekends and maintain the power station? Right, and hopefully the answer is no, you don't. You just use the power. I don't need to think about managing the equipment. But even with, things like infrastructure as service or VMs on the cloud, although the physical server is virtualized, you have to buy it and plug it in, you still have to maintain the environment that runs your code, the Linux, the operating system, the middleware, and all that kind of stuff. And that's not really what I want to be able to do. I want the provider to be able to manage that. Another question is, does your utility provider, when you ring up to get connected, right, when you ring up to get electricity the first time, do they ask you how much capacity you need up front? Do they say, well, how much electricity do you need in 6 weeks' time or 6 months' time, so we can make sure we provision you, connect you to a big enough substation? And again, hopefully, no, this is not how it works, right? You just use the power and then you pay for it. You don't have to think about, resource planning of how much you need. But again, with virtual servers and a lot of infrastructure services in the cloud, I have to decide upfront how much capacity you need, how much CPU and memory and disk space, for load, for traffic that's only going to occur in the future. And it's often very difficult to predict how much capacity you need. And then finally, does your utility provider, does your electricity company, do they ever charge you for unused capacity? Right? Did they ever say, well, we're generating lots of power, excess power, and you're going to have to pay for it if you don't use it? Right? And hopefully, no. You normally, with utilities, you pay for what you use, not what you provision. But again, with many cloud platforms and systems today, when you provision your infrastructure, you decide how much capacity you need up front. And then if you never get that traffic, you never get the amount of load you're expecting, well, guess what? You still have to pay for the capacity you reserve rather than the capacity you use. And I think this starts to show, for me at least, that the way many of us use an infrastructure in the cloud isn't often the kind of utility model that they talk about when we're kind of selling the dream. So the question is obviously, what can we do about this? And this is what I'm here to kind of talk about today, to introduce what we call serverless cloud platforms. And serverless cloud platforms are built as this next generation cloud computing service that for the first time really allows you to use computing resources as a pure utility model, kind of provision on demand, only pay for what you use, and then when you're done, you don't have to manage anything else. Now, let me ask at this point, who in the room has heard this term serverless cloud platform before? Is it new to a lot of you? Okay, so about maybe like a third of the room. Has anyone tried any one of these systems out, like Lambda or Google Cloud Functions or OpenWhisk? Okay, so much for you. All right, yeah, the guy at the back's doing it. So if this term is completely new to you, right, Service Cloud, and you went to Google, to Wikipedia, you're kind of reading up on what it is, you'll read things like this, right? The Service Cloud platforms, they run your code in response to events. They manage all your computing resources for you. They allow you to build event-driven applications. And again, at this point, you might want to stop and kind of scratch your head and think, well, this doesn't sound very revolutionary to me. Right? It sounds like what they all say. Every cloud platform says this kind of thing, right? But serverless cloud platforms are different, and they're different for a couple of reasons. The first is that they shrank the unit of deployment. So rather than having to wrap your code in a huge, VM image with the operating system in and the middleware and the libraries and all that kind of stuff, or even in some kind of monolithic deployment package, with Service Cloud platforms, you push the raw source code for your microservices straight up into the platform, and it gets executed on demand whenever an API request comes in. And this is where the word serverless comes from. It's not that your code is going to run on a server somewhere, but it's from the developer's point of view. You don't have to think about that environment at all. You're going to focus solely on the code and leave everything else up to the platform. Another nice thing about serverless cloud platforms is the scaling, right? Scaling becomes the platform's responsibility. When an API request comes in, your code gets dynamically instantiated on demand in milliseconds to process each request. And so if you get loads of traffic, loads of API requests coming in, all that happens is that the platform spins up multiple instances of your service in parallel to process that load. So you can cope with almost infinite load, and it means as a developer, I don't need to think about scaling in terms of, well, how big a VM do I need with so much memory and disk space to cope with traffic that occurs in the future? It's now the platform's responsibility. And another difference about services, as well as scaling up, it also scales down, and it scales down to 0. Because your code is only running, it gets started on demand to process requests as they come in. So if you don't have any traffic, you don't have any load, any requests to process, guess what? None of your code is actually running. It doesn't sit there idle waiting for requests to come in. It gets started up on demand. And that's really, really important when we think about the pricing model. Right? Serverless cloud platforms, like all cloud APIs and SaaS APIs today, it's pay as you go. You get billed for the milliseconds that your functions are running, times by the amount of memory they allocate. But as I said before, your code gets started on demand to process requests as they come in. So if you have idle time within your application, you have no work to do, no traffic, guess what? You're not going to pay for anything during those periods. And this can be, I think this is a really underappreciated aspect of service, and often is the most disruptive, is the kind of billing model. There's lots of use cases you can go and read online about people talking about moving workloads from traditional infrastructure like VMs as a service over to serverless and saving 80, 90, 95% off their monthly cloud bill, right down from thousands of dollars a month down to just a few hundred, because now you don't have to pay for any of that idle time within your application. Okay, so enough talking about serverless at a very high level and abstract way. Let's actually show you how to use one of these platforms. And to start off with, if you want to start playing around with this new kind of serverless cloud platform stuff, you need a serverless platform provider. Today, there's literally dozens that you can choose from, right? Serverless began almost about 3 years ago now, when Amazon came out with a new service to their cloud called Lambda and kind of kicked off this whole kind of serverless movement. But I think last year, 2016, was the year that serverless really took off, because all of the other big cloud providers kind of said, that sounds like a good idea, we're going to launch kind of competing solutions. So IBM has one called IBM Cloud Functions, I'll be looking at in a moment. Microsoft have one called Azure Functions. Google Cloud have one called Google Cloud Functions. You know, so I can pretty much guarantee you, whoever your cloud provider is, they have one of these serverless offerings for you to be able to play with. Now, the one I'm going to be looking at today is based on an open source project called Apache OpenWhisk. So this is actually the core platform technology at the heart of IBM's commercial offering, that when we developed it and launched it 2 years ago, we open sourced it and have donated the whole project over to Apache. And recently both Red Hat and Adobe have come on board and adopted it as their serverless platform. So it's getting some nice traction in the wider kind of open source community. So if you're evaluating which server, so I said you've got dozens of different serverless platforms to use. If you're evaluating kind of which one you would like to use, there's a couple of good reasons to look at OpenWhisk. The first, obviously, is it's completely open source. So you can obviously use it as a hosted offering on IBM's cloud, but you can download it and run it locally to try it out, or you can kind of deploy it yourself. And the reason that we did this is we think that everyone who builds in the cloud today has some existential fear about vendor lock-in, that you're going to be tied to some proprietary cloud, commercial cloud platform for life, and you'll never be able to get off it if they turn it off or they make it very expensive. Remember what happened to things like Pass.com. So we think by having kind of open source platform at the heart of our serverless offering, it gives you a bit more longer term security about if IBM disappears tomorrow, you're not going to be stuck without a serverless offering to use. But another nice thing about OpenWhisk is the runtime support, and this is probably most relevant for everyone in this room. With service cloud platforms, right, because you don't have to manage or set up the environment your code runs in, you're dependent on the cloud provider to give you the runtimes that you want to be able to use. And if you look across most of the service providers, there's some very common runtimes and some which are much more provider specific. So for example, Node.js. Node.js is the first class serverless language, right? Every service platform out there supports Node at the moment, and OpenWhisk is no different with Node v8. Java and Python are also relatively popular in terms of support. OpenWhisk has support for Python 2.7 and Python 3 and Java 8. And if you look across Lambda and Azure Functions, some of the providers, they're also relatively common. So those three are fairly well supported. Some of the runtimes that are more OpenWhisk specific, and that's kind of what I'm here to talk about today. So PHP, someone recently from the open source community added PHP support in. But OpenWhisk also natively supports Swift, right? IBM has been heavily involved in development of the cross-platform support for Swift and Swift on the server. And so it made sense for us to add native Swift support into the platform. It means you can push up raw, uncompiled Swift code straight into the platform and have it executed as one of these serverless functions, which is a really, really nice feature. And OpenWhisk is the only platform out there at the moment which natively supports serverless Swift. Another cool thing about OpenWhisk is you can actually completely customize the runtime if you really want. You can actually push up custom Docker images with particular runtimes in. So if something doesn't come out of the box, if you want to add Kotlin in or like go mad and use Haskell or something, then you can do that with a custom Docker image. Or if you want to use, Swift 4 at the moment, which is kind of we're still working on, and you want to get ahead of everyone, then you can push that up as well. So we're going to use OpenWhisk for the reasons I've just looked at, primarily that it supports Swift out of the box. The next thing you need to do with your kind of service applications, you need to build some microservices, right? You need to write some Swift code, right? Maybe some Swift code that looks a little bit like this. But the question people have at this stage is, okay, so when I've written some Swift code and I want to execute it on OpenWhisk, right, how does the platform know what to do with it? You've told me I just push the code into the platform and it gets executed on demand, but how does the platform know where and how to interact with my code? You don't have to bundle it up in loads of configuration and all that kind of stuff. Well, with serverless, what happens is for whatever runtime you want to use, whether it's Swift or it's Java or JavaScript or Python, there's just a particular function name you need to add to your source code, and that function is going to be called every time an API request comes in. So this is what it looks like for Swift, right? Imagine you've got this big Swift file with thousands of lines of code in. You need to have a function called main, which takes a named param args with a dictionary of string any and returns a dictionary of string any, and that's going to get called every time an API request comes in, and the JSON that passed in the request gets obviously serialized to the The dictionary and anything you return gets serialized back out as the JSON. So you can see it's very, very simple and lightweight. It's just a particular function name that you add, and then the platform is going to call that every time an API request comes in. Now, this is what it looks like at the moment for Swift. Swift 3.1 is available on the platform. Currently, we're working on Swift 4 support, and the nice thing about Swift 4 is introducing the codable protocol, right, to make it really, really easy to go from JSON to Swift types. And we're going to add native codable support into this, so you'll be able to, rather than using a dictionary of string any and then having to like check all the types and nulls and that kind of stuff, you're going to be able to just serialize straight to custom types. So yeah, it's going on at the moment. It should be here in like a month or something, which will be super nice. Okay, so when you finish your Swift code, you've added that little interface, you push it into the platform, OpenWhisk creates what's called an action. So an action is the name that we use in OpenWhisk for your serverless function that's been deployed, ready to be invoked on demand. So let's do this now. Let's do some live coding, take some code from a laptop, push it into the platform, show you executing on demand without having to set up and manage any of those servers. All right. So I'm going to sit down, drop back to my, I don't know how this is going to work. I need someone to come and just hold it in my face. Okay. So, let me drop my slide. And the screen. Cool. Okay, so, looking good. So OpenWhisk is open source, right? So if you want to, this is a GitHub repo. You can just run it locally for testing around. You can just play around with the platform. You can dig into the Scala code if you're desperate to see how it works. But I think for most people, the easiest thing to do is to go to IBM Cloud. You sign up for a free account, and you get it's called IBM Cloud Functions. It's just a hosted, managed instance of the OpenWhisk platform. It comes with like a really generous free tier, so you get more gigabyte milliseconds to play with than you're ever really going to use, and it's just really easy to get started. And that's the one I'm going to be using today. But you can use OpenWhisk locally, or you can use another provider. It's absolutely, it's all the same platform. So the thing you need to do once you've signed up for your account with your OpenWhisk instance is you need some way to get your Swift code into the platform. And to do this, there's just a little CLI that you download and install that allows you to create new serverless functions from Swift code and then execute them on demand. So let's have a look at doing this. Let me take you through a kind of hello world example. So if I go to my terminal now, okay, I have this little binary. Let's make that a little bit bigger. There we go. There we go. Right, so I have a utility tool, which is the Whisk command line tool, which allows me to interact with the platform, right? To create service functions, invoke them, and kind of interact with the remote cloud instance. So let's do a hello world example, right? My first serverless function. So I have some Swift code here. So you can see it's super simple, right? It's just a Swift file, which obviously has a function called main in. So it's going to be the entry point of the platform into my code. And it's just going to return me a greeting. It's going to say hello stranger, or hello James, or hello Sally, depending on the parameters I pass in. So let's create a new serverless function from that. I can say, okay, whisk action create hello. I obviously give it a path to the source file. And then I can make that a little bit bigger. There we go, right? Pass it the name of the source file, and it's going to then create it on the serverless cloud platform. So I can check that it's been instantiated correctly. So type whisk action list. You can see my workspace of a new action called hello using the Swift 3.1 runtime. So now I can test it out. I can say whisk action invoke hello. And hopefully what it should do then, it should ask the platform to evaluate my Swift code, call that function, and then serialize me back out the response of that Swift code as some JSON on the command line, right? So there we go, greeting stranger. And you can see I can pass in the parameter for the name. So I can say, right, hello James, or hello Sally. And it's just going to work, right? I could call this function 1,000 times in parallel, and it just works. I need to set up and manage the environment, the Linux environment which runs my server-side Swift. It just kind of works, which is super nice. Now, obviously, this is like the hello world example, right? It's not very useful to have this as a microservice. So let's walk through something that's maybe a little bit more realistic. Right? Imagine you're building a mobile app for a retail site, so you can buy things through the mobile app, and the retailer has the brilliant idea they want to integrate Bitcoin into their application, right? And so people can pay using Bitcoin. Now, Bitcoin as a currency fluctuates a lot day to day, right? So changes hour to hour the price. So you're not going to put the Bitcoin prices for your products in the database. You're going to want some kind of API you can talk to convert from dollars or pounds straight into Bitcoin at that checkout process. So I think this is a good use case for a serverless function, and I've written some Swift code to be able to do this, and now I just want to kind of deploy it and try it out. So I have some slightly more lengthy, more realistic Swift code here, and I'll just kind of walk you through it, and then we'll get it deployed and show you it working. So I've got this kind of, it's probably about 30 or 40 lines of Swift, but it's pretty simple, right? I have a function called main, so that's obviously going to be the entry point. When the platform API comes in, it's going to call the function main. You need it's going to expect two parameters. It's going to expect a currency and an amount, obviously the amount and the currency to convert into Bitcoin. And then we go and make a HTTP request. So what it does is CoinDesk is an external Bitcoin wallet, and it publishes real-time prices of Bitcoin and other currencies. So it goes and makes an async HTTP request to CoinDesk, passes the JSON that comes back, and then down the bottom it just does a tiny bit of maths to translate from one currency over into Bitcoin, and then returns you the amount. So let's try this out, right? Let me see, say whisk action create Bitcoin, conversion.swift. Cool. Check it's working. Whisk action list. Yeah, that's there. So now I can try out. So I'm going to say, okay, invoke the Bitcoin function. I need to pass in two parameters. So I need to pass in an amount. Let's do like 1,000, 10,000, because Bitcoin is very expensive. And let's try US dollars. So hopefully, again, it's going to invoke my Swift code. It's going to go and call that API. It's going to do the JSON processing, and it's going to tell me that 10,000 US dollars is 1.18 Bitcoin, right? So Bitcoin's super expensive these days. And I can call this again, right? I can say, okay, so what about if euros, probably a bit less Bitcoin, and then a pound, even less Bitcoin. So now I've got this little serverless Bitcoin function, right, that I can call on demand during my checkout process to do the conversion. And I don't need to, as I said, don't need to think about managing the environments or servers or any kind of stuff. All I've had to do is write some Swift code, and it kind of executes on demand. Now, once you have got your serverless functions kind of deployed, right, then obviously the next step is how can you integrate them into your application? How can you kind of call them programmatically from mobile app or some other kind of application to kind of execute them on demand? Obviously you're not going to use the command line to do that. So OpenWhisk has a couple of different ways to be able to integrate your functions kind of into other applications. And the first is through something we call the platform API. So OpenWhisk has a very well documented RESTful HTTP API for interacting with the platform. And any application you can send just an authenticated HTTP request to, you can integrate evaluate your functions on demand. So when I was using the command line there, when I use the command line, I say whisk action create, whisk action list. All the command line tool does under the covers is send HTTP requests over to the platform using your developer credentials. And there is client libraries available for Swift and JavaScript and other language to make this even easier. So if you, so rather than having to manually mess around with HTTP traffic and that kind of stuff, you can choose the command line, the client library, and it makes it super easy to do. And now, if you're using if you want to talk to the platform API, it has to be all requests are authenticated with your developer credentials. But often when we're building kind of APIs, we want to make them public. We want to make other people be able to call them, and obviously we're not going to give them our developer credentials. So OpenWhisk has actually two kind of nice features that allow you to quickly expose your serverless functions as public HTTP endpoints. And the first is using something we call a web action. So when you're creating the serverless functions on the command line, there's a flag you can set, --web, to true. And what that does is the platform will generate you a unique URL on the platform that you can call without requiring any credentials at all. So it gives you a unique random URL on the platform that you can call with an unauthenticated HTTP request to just invoke that platform on those functions on demand. So if you need to, it's really nice if you just need a really quick way to expose your function for like a webhook or maybe for a chatbot or something like that, very simple. Webhooks, web actions are a really nice way to convert your serverless functions into public URL endpoints. Now, if maybe you're building big, more high traffic enterprise APIs, you're probably thinking at this point, well, what about like API routing? I want to call different serverless functions depending on the operation and the path of the requests coming in. What about things like rate limiting? I don't want people to call my serverless function too much and cost me too much money. What about authentication? And I want the user to be able to pass in OAuth credentials that I can use with third-party services. And if you're going to use web actions directly to implement your API, you have to kind of implement all of those features kind of manually in the code. So you need to look at the request parameters coming in and kind of work out how to do things like rate limiting and routing. And actually, that's not a very scalable or sensible approach if you're building very big, high-traffic APIs. So what everyone does, this is the pattern, the architectural pattern for building kind of enterprise, big, high-traffic APIs with serverless platforms, is to use a third-party service called an API gateway. So all big cloud providers have these kind of services. IBM has one called API Connect. Amazon has one called API Gateway. Google acquired Apogee recently to do this. And what API gateways allow you to do is create public API endpoints and then call private APIs in the background. And you can use this to then create your public endpoints for your serverless functions. And the good thing about API gateways is that they handle all of those features for you. So things like rate limiting and routing and authentication is managed by the API gateway service, and you don't need to handle that in your code whatsoever. So this is the pattern, the strategy. If you're going to build kind of bigger, more high traffic profile APIs, go and stick an API gateway in front to manage all of that kind of more enterprise stuff. So let's try this out now. Let me take my Bitcoin function and let's expose it as just a public HTTP endpoint that anyone could access. And we'll start by doing just as a web action, and then we'll look at doing the API gateway integration as well. So let me sit that down and drop back to my terminal. Okay, cool. So let's go back to the terminal. And let's start with what I showed you. Let's create one of those web actions. So you can see that I already have my action deployed. So I'm just going to update it. I'm going to say whisk action update Bitcoin -- web. So I'm setting the web flag to true. And then I can say, OK, now give me the URL that you've created for it. So now I have this URL and copy that I can call. I've got a utility on my command line to make HTTP requests easily. And I can call Bitcoin. I'm going to say I want the content type JSON back. You need to pass in the query parameters, so we just use URL params. And a currency, let's try US dollars again. And hopefully, again, it should just give me back over HTTP endpoint the result of calling my Bitcoin serverless function. So there we go, right? There's the HTTP headers, and there's the JSON, serialized to JSON, the response of my serverless function. And I can see, you know, again, I can try it with euros, and then it should just work. So now, really, really easily, I've exposed it as a public URL that anyone in this room can start to call and use by setting my action into web action, which is really nice for just quick, easy testing or doing something like a webhook or chatbot where you just want something kind of quick and fast. Now imagine that, imagine my Bitcoin API gets very, very popular because it's, you know, it's super awesome. And so I want to manage things like rate limiting or authentication, so I want to add in that API gateway integration. Now OpenWhisk actually comes built in with an API gateway that you can manage from the command line. So I can say whisk API create, whisk API delete, but I think it makes more sense if I show you setting up the API gateway through the web interface that comes with IBM Cloud Functions for reasons I'll kind of talk about in a minute. Now, when I was practicing this talk, literally only yesterday, I realized that they have pushed an update to the service overnight. And in America, it's Thanksgiving, so they've all now gone on holiday, and they've broken the service, and then they've just gone on vacation. So I opened a ticket, but they haven't fixed it. So luckily for you all, I have a video backup of what I was going to do for the next part of this demo. Yeah, look, it's all broken. Look at that horrible square box. So you click Create API, and then you click here, and nothing happens. So while they're all relaxing over Thanksgiving, they've broken the API. So luckily, I always record video backup. Here we go. So let me skip to where I was in the talk. Here we go. Okay. So this is what it should look like. So put that full screen. Pretend I'm typing. So you click, if you go and click Create an API, so this is just the web management console for IBM Cloud Functions. Create an API, and you can go in and you can give your API name, call it Bitcoin, and then you can see I can start to put in the path, right? I can start to use the API gateway to do routing, to say, okay, when someone calls /API and they call the path Bitcoin, and it's going to be a GET request, and it's going to be an action Bitcoin, and I want some JSON back, then the API gateway will manage that. It's call my serverless function, and you can see I can now turn on those features we talked about. So I can quickly turn on authentication or rate limiting or OAuth or core support, and I don't need to think about it in the source code, which is super nice. So I click save, and what it's going to give me is a URL for the platform. So this, you see, this is not a platform URL, this is API gateway endpoint. And I can then call that from the command line, and it should be exactly the same. I should just be able to call it and then get back the result of my Bitcoin API. So now I say, okay, call API Bitcoin, and I give it an amount, and I give it a currency. And it should, I know it definitely works because there's a video. There we go, it works, amazing. So you can see now what I did in the video was that I exposed really, really quickly my serverless function as a proper API endpoint that then you can manage all those enterprise features. So it's a really, really nice way to add those cool features in, but it's really, really quick and easy to do. So if you're going to be building bigger, more high traffic profile APIs, you need to be using an API gateway service with kind of serverless functions. Okay, what is it? Is that one? Cool. Okay. Yeah. So you can see how relatively easy and straightforward it is, right? Take some Swift code, deploy it, and then I can kind of invoke it on demand using something like an API. Now, the examples I've just been talking about or just been showing you, it's all been about using serverless platforms to build some kind of API endpoint that you invoke programmatically. You're going to block waiting for the response to come back. But one of the other big use cases, maybe the bigger use case, I think, for serverless cloud platforms is building what they call kind of event-driven architectures or asynchronous processing, where you can connect your serverless functions to external event sources like message queues and databases being updated, so that whenever there's a new message getting pushed on the queue, your serverless function gets invoked on demand to process those events without you having to do anything. And OpenWhisk supports this using a concept that it has called triggers. So in the platform, you can create triggers which listen to these external event sources. So that can be a message queue, or it can be a database or an object store. And whenever that external event source fires, when there's a new message on the queue, the platform will automatically invoke your triggers with those event details for processing. And to create triggers, again, you just use the command line. You say whisk trigger create. And there's a flag, -- feed, where you give it the name of the event source and any details about how to connect to it. Now, all serverless platforms support this kind of operation where you can connect your functions to event sources and have them invoked automatically by the platform. But the difference is the event sources they support are very, very provider specific. So for example, these are the 6 event sources that OpenWhisk kind of supports out of the box at the moment. So it has support for Apache Kafka. Kafka is a very popular open source distributed message queue. So whenever there's new messages on a Kafka queue, you can have the trigger firing automatically. There's an event source of CouchDB, which is another Apache project. It's a very popular open source database. And whenever there's any changes to the JSON documents, you can get those trigger events firing. There's one for RSS feeds. There's one for mobile device events if you're on IBM Cloud. There's one for GitHub. And there's also one for doing kind of periodic or scheduled events. So you can have event triggered every 5 minutes, every hour, every day to be able to kick off background processing. And in OpenWhisk, when you've created your trigger listening to one of those event sources, you can then create rules which bind together your actions with the trigger. So whenever the message gets pushed on the queue, the trigger fires, and then the rule will automatically fire your service function with those event details. And you can have multiple service functions all listening to the same event source, which is a really, really nice pattern. And again, to create the rule, all you do is use the command line and you say whisk rule create. You give it a name of rule, you give it the trigger and the action, and the platform will then bind them together. It's going to start listening to that event source and then evoke your action every time there's a new message or the database has been updated. And that's how you can start to build kind of event-driven or kind of asynchronous applications using the platform. Now, hopefully, over the past kind of half an hour, I've kind of helped to share why I'm so excited about serverless cloud platforms, right? Why I think it's such a new and interesting way to build software for the cloud. And maybe I've managed to convince you, right, that servers kill your productivity, you're ready to go back to the office and start setting fire to all of those Linux machines. But before I do that, before we start burning all your servers, it's only fair for me to talk about some of the challenges of using serverless cloud platforms, because they're still very new and kind of emerging technologies, and there's lots of trade-offs and constraints at the moment. And so it's only fair that I kind of talk about a couple of things you might run into and then provide, hopefully, some solutions. So the first challenge that you probably run into, and this is very, very specific for Swift really, is understanding the difference between what we call warm versus cold activations, and really the effects this can have on performance of your API endpoints. And this is a kind of characteristic of the system of all service platforms, but really, really specifically affects Swift much more than others. So to explain this, I'm going to see if you spotted something. When I was doing my demos before, what some of you in the audience may have noticed was that the first time, after creating the serverless function, the first time I invoke it, it was always a little bit slower than the subsequent invocations, right? And that wasn't due to some bad Wi-Fi or some network effects. It's kind of inherent in how serverless platforms work. And to explain why that is, why the first invocation is always a little bit slower, I'm going to have to drop into how serverless platforms work, kind of under the covers. So when you type whisk action invoke, a number of things have to happen before you get the results of your code being serialized back out to JSON. And these are the kind of high-level steps, right? The first time when you're having created a function, the first time you invoke it, what happens is it starts a container, starts a Docker container to be able to run your code, injects the code into the environment on the file system. Obviously, Swift is a compiled language, so it runs a Swift build. Then it calls your function main with the event parameters and then serializes back out the response from the platform API. Now, the main source of delay in those steps is actually running the Swift build, right? Swift build is not known for being notoriously fast and is generally the first time you invoke a function, and we call it a cold invocation. It's normally the Swift build that is the source of that delay. Now, to improve performance for subsequent invocations, rather than throwing that environment away and starting from scratch next time, what the serverless platforms do is they actually pause the container. So if you then try and invoke it again, what happens is it doesn't need to, it just resumes the environment, doesn't need to inject your code, doesn't need to run the Swift build, just calls the binary again with the new event parameters. And that's why subsequent invocations are much faster. And this affects Swift more than other runtimes, because with JavaScript or Python, you don't need to run the Swift build, you just kind of evaluate it dynamically. So if this is, the question is, obviously, does this affect you, right? If you are building, some function that listens to messages on a queue, you probably don't really care about the difference between warm and cold activation times. But if you're building something that's very latency sensitive, if you are building APIs, you want them to be as fast as possible, that might be something that's going to be a bit of a problem for you. So the technique here, the trick to fixing this, is that actually what you can do is you can run the Swift build locally, and when you create your serverless functions, you can create them from the binary, not the Swift code. And that means that during cold activations, what happens is when you inject the code into the platform detects it's a binary rather than the Swift source file, and it won't run the build system, so it's much, much quicker during this cold activation time. So you can see in this this very unscientific experiment I did, the invocation time for warm or cold actions dropped by like 3 seconds or something. So again, to improve performance, if you're really concerned about the latency and the difference, you can run the Swift build locally and upload that. Okay, so next challenge, final challenge that you might run into, and this is more general, this is for all runtimes, it's not very Swift specific, is around compute limits, right? Limits that the platforms put on some of the resources that you have available to you. Because service cloud platforms, they're very opinionated platforms, and they're opinionated about the kind of architecture of application it expects to run, right? Service cloud platforms are not for lifting and shifting legacy apps over to run in the cloud. Not that if you're doing Swift on the back end, you don't have any legacy Swift apps at the moment. But it's for modern cloud-native microservices designed to kind of run and exploit the efficiencies of public cloud. And one of the ways they enforce this architectural style on you is by limiting access to some of your resources. So for example, these are some of the constraints and limits you have running on OpenWhisk. And it's the same for pretty much, all service platforms are kind of designed in the same way. The two big ones you're going to run into, the first is around timeouts. So when your Swift function gets called, or your JavaScript function or your Python function to process a request, you have a maximum of 5 minutes, right? 5 minutes to process that, to do whatever computation, and then return it back out. If your code hasn't finished running after 5 minutes, the platform just kills off the environment and returns an error code through the platform API. All service platforms have settled on around 5 or 10 minutes as this hard limit. You can't get past it. It's just kind of an architecture of service platforms. They're for quick request response style processing. It's not for super long batch jobs. So if you do have some complex algorithm that takes like an hour to compute and you can't parallelize the work or something, it's not really going to be appropriate for serverless at the moment. Another one people run into, one of the limits is around memory. So obviously your serverless functions, you get charged for the milliseconds that your code is running, but also the amount of memory it uses. And you can change the maximum amount of memory available to improve performance, but then obviously control the cost. But the amount of memory you can give a function is like a gigabyte or half a gigabyte or 2 gigabytes. You can't have a function using terabytes of RAM. So again, if you've got some very high performance algorithm which needs like 2 terabytes of RAM to compute really, really quickly, it's not really going to be an appropriate workload for running on serverless at the moment. So my advice here is around the limits. Is one, obviously understand the limits of the platform and then kind of embrace them. Right, they're there to help you. They're there to help you build your applications to run in the public cloud and exploit like kind of horizontal scaling and stateless microservices. Don't kind of fight them because you're not going to win. Okay, so I said at the start of this talk that servers kill your productivity, and hopefully maybe now you agree with me, right? All the time you would spend managing VMs or containers and patching kernels and worry about scaling and resource planning, it's not really productive time, right? It's kind of time wasted. You want to spend time in Xcode writing Swift, not on managing VMs in someone else's data center. And I think as developers, it can often feel like you get held hostage by your infrastructure. I want to spend time writing code and spend increasing amounts of it kind of debugging Linux kernel panics to run my code in the cloud. So I want to encourage you all here today, right? If you're starting to write Swift on the server, start to build backends in Swift and push them into the cloud, think about embracing the serverless revolution, right? Burn your servers, deprovision your virtual machines, delete your containers, be free forever of the tyranny of looking after infrastructure. But most importantly, right, upgrade your productivity. Get back to writing code, not on managing infrastructure in someone else's data center. So thank you very much for listening. If you want any of the resources from this talk, probably everyone just takes a photo these days. Take a photo of the screen or use your brain. Remember, there's a bit.ly link at the top, bit.ly burn your servers, and that'll take you to a GitHub repo with all the examples and code and walkthrough for you to play around at home. If you like OpenWhisk and you want to start doing some serverless Swift, we obviously have a Slack channel. We can come and hang out, or you post questions on Stack Overflow, and people like me will be answering them. Or follow me on Twitter. Mostly all I talk about these days on there is serverless and Swift. And you can always tweet me and ask for help if you get stuck. So yeah, so thank you very much. I think we have about 5 minutes for questions as well.
Hi James, my name is Mike, people of the company. I'd like to ask not trivial questions like, except for the not supporting of Swift language in FM by Oracle, what is the main difference between OpenWhisk and FM by Oracle?
That's a good question. So FN is a new open source serverless platform that Oracle have recently announced. So they kind of got into serverless. I saw a talk on it recently, but I haven't really played with it, so I'm not sure what the kind of technical difference is. I know FN is much more focused on Docker containers as the runtime, I think. So with OpenWhisk, you can either push the code up or you can push a Docker container as well. I think the FN project is more focused on just pushing Docker containers up. I don't know if Oracle have a hosted FN project at the moment, so I guess that's one of the things as well. I think it's great that OpenWhisk is open source, but generally you don't want to run the platform yourself unless you have some requirement around having to be on premise or something like that. Generally, I think one of the big benefits of service is the pricing and the cost and the scaling, and that comes from using a hosted offering. So I'd say that's, at the moment, I don't think they have a hosted offering for you just to be able to use. You have to run it yourself, which it takes away one of the benefits, not all of them, but one of the benefits. But it'll be interesting to see where they go with it. It's super new. They only announced it like a month ago, and it was FN was based on another open source project that they acquired last year. So yeah, it's a very busy space. There's lots of serverless stuff at the moment.
Hello, James. Thanks for a nice talk. So my question will be not strictly about serverless, but about server-side Swift in general. So how to convince your manager to use server-side Swift on production on real projects? Maybe you would suggest something, make some succeeded stories. Some brands, some big companies which uses server-side Swift on production.
I think that's a good question. How do you convince your managers to use Swift on the server? I think you can tell them that they could fire all those backend developers, and then you can just do it because you know Swift, and then you can build it in the backend and save it. I mean, it comes down to, that's a good question. I I mean, obviously, I mean, it does mean that you can be if you have developers that are just used to doing the front end, you can go full stack, right? So because you can do Swift on the server, I can not just build the mobile app, I can build the back-end services as well, right? So you can start to be a kind of full stack in the same way that you saw with JavaScript. JavaScript used to just be a browser, and then Node came along, and now you can start to do JavaScript everywhere. So I think you will start to see that. I mean, the nice thing I think is, one, Swift has really good performance characteristics. So I mean, I've seen some, I think Chris Latner has some slides where he compares like certain workloads in Swift and I don't know, like every language, and Swift is one of the most performant out there in terms of speed and memory usage. And when you think about it, when you're running in the cloud, you get charged on, on the memory and the CPU that you use basically. So having performant languages that compile to binary, I think is a really compelling use case for getting the most out of your money. So I think performance characteristics, Swift seems like it's really, really good. Developer happiness is always a good one. Tell them you'll leave otherwise. I don't know. It's not super easy. But I think yeah, the ability to use the same language, share code. If you're building libraries and utilities. Often you have to have the same capability in the back end. If you're processing, like validating requests or that kind of stuff, you end up re-implementing the same libraries in different languages because of that. So yeah, I think yeah, just try it out.
Thank you for a great talk.
Hey, thank you.
I had a question about the best approaches to work with databases in the serverless architecture.
Yeah.
So as I understand, the Bluemix, do they provide some convenient way for this?
Yeah, so that's a good question. That's probably the most common question I get from people who are more newer to cloud development is like, well, okay, if I don't have a server, where's my database, right? And what happens is that when you're with serverless, you write the code yourself, but then you push out as much as possible to the platform, right? So you'll use a hosted managed database from whoever your cloud provider is. And what happens generally is that the way it works is the cloud provider, in OpenWhisk, we inject the credentials of that database into the environment through event parameters so that you can just read them and then connect your database. So yeah, if you're running an IBM cloud, we have like every open source database under the sun as a managed solution. So you've got Redis or MySQL or Mongo or we have a company called Compose we acquired, which does open source databases as a service. So yeah, there's loads for you to be able to choose from. CouchDB is probably the most popular one for people at the moment because it has good integration with OpenWhisk. It's just a very popular open source NoSQL kind of JSON database. So Couch is really nice. But yeah, whatever you want to use, MySQL or Postgres, or there's 1,000 for you to choose from. So yeah, generally use a hosted offering from your, you don't run a service and then put a database on it. You then just use whatever managed offering comes from your provider.
Yeah, I think you would need to try this.
Yeah. Okay. Question at the back.
Thanks, James. A good talk. I couldn't help but notice that OpenWhisk seems like a really, really best match for the startups. Let's say where when you don't have many developers and you just can do the full stack as a co-founder or whatever, tech lead. The question is the cost of running OpenWhisk comparable to the mainstream AWS, Amazon Web Services? I mean, Amazon is cheap and scalable. So how about that?
It's a good question. So in terms of cost, I'm thinking for the hosted offering, all the service providers have kind of settled on the same price, which is whatever Lambda uses as their price. It's so small. It's like 7 cents per million gigabyte seconds or something. So in terms of cost, it's super cheap. And there was a research paper published recently looking at different workloads on serverless. They compared VMs and containers and serverless, and they found on average for the average workload, serverless is always much cheaper, basically. So because people have said, well, if you've got consistent load and blah blah blah, is it maybe it's cheaper to do Kubernetes? And this research paper from a company called 451 Research, who are an analyst firm, showed that on average it's much cheaper to use serverless. I think in terms of, you also kind of touched on another point, is this just for startups? Because for startups it's nice because your costs scale linearly with the amount of work, right? You'd have to provision loads of capacity, hopefully that customers arrive. If no customers arrive, well, you're not going to pay anything, but your costs will scale linearly. But actually, so serverless is great for startups or anyone, but you'll be surprised how big enterprises are kind of, it sneaks into big enterprises, and big people are using serverless cloud platforms. So Expedia are a huge global travel site, right? Their CTO often tweets out their statistics about how many serverless function calls they're doing a month, and it's like 7 billion at the moment. And they say it costs them less than it costs to rent a house in San Francisco. So, Capital One are a huge credit card, global credit card processing company. They're massive adopters of service. So lots of Coca-Cola as well. IBM has customers that we use it for millions of stuff a month. So you'd be surprised how it kind of sneaks into enterprise. It's not just startups. So it's very applicable because it's so cheap and easy. It's kind of easy just to throw some code up and use it, even if they don't really know about it. So I think it's getting really big adoption. And I think for Swift developers and mobile developers, it's awesome because it means that you can write some backend. I think for a lot of, if you're used to doing mobile apps, you probably think, oh, if I want to write some backend services, I've got to learn like Docker and Kubernetes and orchestration and all this kind of ops stuff. And with serverless, you don't. You just write some code and you throw it up and it executes. So I think for mobile developers who maybe don't have all that expertise in the operations side and think, oh, is it really worth it? I'll push it to the ops teams. It means that you can go full stack, right? You can build some backend services. All it is Swift code that executes on demand. So I think for mobile, it's a really big area for you guys to start to do backend work without having to just skip out all the whole Kubernetes Docker stuff. So yeah. Okay. Yeah.
Hello, my name is Roman, and I have a question. How do you think serverless solutions appears only for price reason, or there are another reasons why we have them?
I think it's. Is it just price? I don't think it's just price. I think that it's the natural. For me, it's the natural evolution of the cloud. Right, with the cloud, you started with a virtual server, right? So it was just a VM somewhere, and then it kind of moved to containers, and there was some, and at each stage you're getting further away, you're getting higher up the stack away from the actual environment your code runs in. And this is the natural evolution. It's literally, well, why do I have to do anything? Why can't I just literally give you the code and you execute it? I don't want to think about Linux or containers or, I just want, all of us just want our code to execute when some kind of API request comes in. So I think it's the natural evolution of that you push more to the platform. Which means they manage it and you can just focus on doing the business value. There's not a lot of business value for a lot of people in doing, your customers don't care whether you run your server, whether you have a physical server or use a virtual server or use a container. Like, it's irrelevant to the value you generate for your customers, right? So why spend time doing that kind of stuff? And I think it's the move to utility computing that, like with your electricity provider, if someone said, well, I need to start a business, I'm going to build a power station to give me power, you'd say that's ridiculous, right? You go and use a utility, and it's the move to utility compute. But I think that the pricing will be really disruptive because you only pay for this time you use, and no other solution can provide that. So I think that people that adopt serverless could see a cost advantage to bring products and services to market faster and for cheaper. That becomes like a business advantage, basically. So yeah, I think it's multi-factors, but I think the pricing is probably the most disruptive aspect of it. People focus very much on the technology. I think it's more the pricing model. But yeah, I guess we'll see.